fourth graders. Welcome to week 9, where we are learning about probability. Yesterday, we worked on finding the outcome of a simple event. Today, we are going to be looking at a number line. Our I can statement is I can represent probability as a number between 0 and 1. The materials you will need today, you will need a pencil, paper, and a random number generator. All that is dice. If you don't have any on hand, you can always find some online to use. All right, we are going to look at the number line first. So probability on a number line. We saw 0 and 1 yesterday. 0 being impossible, something that could never happen. 1 being certain, something that will happen every single time. Then I put half here. And normally, if something happens less than half of the time, we say it is unlikely to happen. If something can happen more than half of the time, we say that's likely. And that's not always, but normally that is a pretty good guideline as to where we can put our results on our number line. So looking at the words impossible, unlikely, likely, and certain, we are going to sort through some phrases. So the first one, you will watch television tomorrow. Number 2, the sun will rise tomorrow. 3, it will be snowy tonight. 4, there will be no school tomorrow. 5, rolling a 4 on a random number generator, which is dice. 6, you will see a live dinosaur tomorrow. 7, you will solve a math problem correctly today. And 8, you will have 2 birthdays this year. All right, so pause the video and then you are going to decide if the phrase is impossible, unlikely, meaning less than half of the time, likely, which is more than half of the time, or certain, which is all of the time. All right, so write down or decide in your head which word goes with each of these phrases, and then you can resume the video to see how you did. All right, so impossible. Number 6, you will see a live dinosaur tomorrow. Not gonna happen. All right, number 8, you will have 2 birthdays this year. As much as that would be nice, it's not gonna happen. All right, unlikely. It will be snowy tonight. Well, it could, but very, very, very unlikely. Rolling a 4 on a random number generator. It definitely can happen, but there are 6 options. So getting just that one number, it's unlikely to do. What is likely? You will watch television tomorrow. Possibly, so it's more than half the chance you'll probably do that, likely. You will solve a math problem correctly today. Hopefully you've already solved one correctly, so hopefully we're already there. Certain, the sun will rise tomorrow. Rises every day. And because of our situation that we're in, it is certain that there will be no school tomorrow. Definitely not going to happen. All right, so moving on, we're going to look at equally likely. So a lot of times if there are only 2 options, equally likely would be half, because it's either it is or it isn't. But let's look at our spinner from yesterday. We had 4 outcomes. We had red, blue, green, or yellow. Those were equally likely. They are 1/4. So looking at this, we would say, oh, that's unlikely. But because they all are the same, we use the word equally likely to describe them. They are all equally likely to occur. So it just means that 2 or more outcomes have the same chance of occurring. Okay, so using one random number generator, what is the probability that a 4 will be rolled? You don't even have to roll it right now. You just have to think about it. It has the numbers 1, 2, 3, 4, 5, 6. What is the probability that a 4 will be rolled? All right, using a random number generator, what is the probability that a 6 will be rolled? And what other numbers on the random number generator have the same probability as 6? Okay, so that first question, having the 4 is 1/6, because there's only 1 4 on this whole thing, and there are 6 sides, so it's 1 out of 6. Using the random number generator, the probability of rolling a 6 is the same. There's only 1 6, and there are 6 sides, so we have 6 outcomes, 6 different outcomes. What other numbers on the random number generator have the same probability as 6? 1, 2, 3, and 4 all have the same probability as 6. They all have just one side on there. All right, so when using a random number generator, what outcome is impossible? So what outcome could never, ever happen? Rolling a W. So there are no letters on there. So anything that is not on there would be impossible. So a letter, different words, colors, you could say red. It's impossible to roll red. All right, when using a random number generator, what outcome is certain? So what will always happen? We will always roll a number. It's never going to be anything but a number. You could say the number is 1, 2, 3, 4, 5, 6. You could say the number is less than 7. When using a random number generator, what outcome is equally likely? Rolling even and odd numbers. 1, 2, 3, 4, 5, 6. Those are our choices. 1, 3, and 5 are odd. 2, 4, and 6 are even. There are 3 of each. So it shows us 1, 6 plus 1, 6 plus 1, 6. That's 3 out of 6. And even is also 3 out of 6. So they are equally likely to get even or odd. All right, so now it's your turn to practice some. What is the probability of rolling a number greater than 2? All right, so in the box below, list the sample space or all possible outcomes and circle the favorable outcome. So you're going to list all of the results that could possibly happen and then circle the ones that are greater than 2. All right, identify the fraction or measure of probability for rolling a number greater than 2. So here's where we're going to write the fraction. Circle the probability that you would apply to the chance of rolling a number greater than 2. So is it impossible, unlikely, equally likely, likely, or certain? And then D, roll the number cube 10 times and keep a tally of your results in the chart below. So if you don't have something to roll, then you may see if you can find something on the internet. They have lots of different dice, random number generators, or number cubes that you could roll that have 6 sides. And how do the results of your trial compare to the probability of rolling a number greater than 2 occurring? All right, so we're looking for a number greater than 2. We're going to be doing the same thing, but now we're looking for a factor of 6. So all possible outcomes, and then circle the ones that are factors of 6. What is the fraction or measure of probability for rolling a factor of 6? Then we're going to circle the term that would apply to the chance of rolling a factor of 6. Then you're going to roll 10 times, keep track, and then how do your results compare to the probability of rolling the factor of 6? All right, a number less than 7. So same thing for a number less than 7, and then back to a number greater than 6. All right, I'm going to go back. So when you're ready now, you can push pause to work on greater than 2. Then when you've done that one, you can proceed to factors of 6. Pause here, work on this one. When you're finished, you can push play to do the next one. So now we're going to be doing a number less than 7. So go ahead and push pause to do the number less than 7. And the last one is a number greater than 6. So pause, and when you're finished with all of them, push play so that we can check the work. All right, so how did you do? A number greater than 2. So all of our possible outcomes, 1, 2, 3, 4, 5, 6. What numbers are greater than 2? 3, 4, 5, and 6. So our fraction or measure of probability is 4 out of 6. So that's more than half. That is likely that we will roll a number greater than 2. All right, so I rolled 10 times and I got 1, 1, 2 2s, 2 3s, 2 4s, 1 5, and 3 6s. So do the results of your trial compare to the probability of rolling a number greater than 2? So I rolled 8 out of 10 were greater than 2, which is likely. So both of them are likely. I rolled mine 8 out of 10 times. All right, so the next one, factors of 6. So here, 1, 2, 3, 4, 5, 6 are all of our outcomes. 1, 2, 3, and 6 are our factors. So my fraction would be 4 out of 6, which is likely. And then I rolled, and here are my results. And then 7 out of 10 were factors of 6, which is still more than half. So I call that likely. So it was the same. It was similar to the one that I had predicted. All right, and then numbers less than 7. So 1, 2, 3, 4, 5, 6. So all of those are less than 7. So 6 out of 6. So it is certain that I'll be rolling a number that is less than 7. So my chart of what I rolled, and then 10 out of 10, all of my rolls were less than 7 because there are no numbers larger than 7 on my dice. All right. Now a number greater than 6. So 1, 2, 3, 4, 5, 6. Identify the fraction or measure probability for rolling a number greater than 6. So none of those numbers are greater than 6. So it is impossible to roll a number greater than 6. And I rolled my numbers and 0 were greater than 6. So it is impossible. So it is the same. All right, so today we looked at the number line. We looked at where we could represent the probability on the number line using the terms impossible, unlikely, likely, certain, and equally likely. So I can represent probability as a number between 0 and 1, and we are using a number line to help us do that. So hopefully we are a little more comfortable with number lines and probability, and we will come back tomorrow to do some literature in our math. So hopefully we'll see you back tomorrow for Wednesday's lesson.